Throughout the next few videos, we'll be discussing how to program the machining of this bracket using Fusion 360. Before we can begin creating any toolpath operations, we must create a setup. The setup will define our work coordinate system and location, our version of the gnomon, stock dimensions, and operation type. Let's begin with the part on the right, which we will define as our setup 1. To create a setup, pick the setup command from the toolbar. This opens the setup dialog box and shows a preview of the current origin, WCS orientation, and stock. Firstly, we need to select our operation type. The operations available are milling, turning, or cutting. I'm going to select milling. Now that I've told Fusion what type of process I want to do, I'll start out by defining my model geometry. When more than one body is present, Fusion defaults to selecting nothing as the model geometry. So, I'll select my part to tell Fusion which bodies I want to include in my model geometry. I can select bodies by clicking them directly, or I can select bodies from the feature tree. Now that we have selected our model geometry, you will notice that Fusion has updated the yellow stock preview to fit the model selection. Note that you can cancel all of your selections at any time by clicking the X in the model selection dialog or re-clicking the highlighted body in the model or feature tree. For model-based toolpaths, only bodies identified as model geometry will be considered during toolpath calculations. In addition to selecting model geometry, we can also identify any fixture geometry the same way we selected model geometry. Defining fixture geometry is not essential, however, it is useful as it allows Fusion 360 to identify potential collisions with fixtures during stock simulation. Now that we have identified our model and fixture geometry, we return to our WCS selection, shown with what we call a triad, and what you might have called a gnomon in Mastercam. Fusion allows you to set the WCS relative to the model no matter how it's oriented, giving you flexibility regardless of who did the design work. By default, we can see our orientation will be defined from the model orientation. By selecting the dropdown, we can see the options we have for selecting our WCS orientations. We can select a combination of any of the two X, Y, or Z axes, or select an existing coordinate system from our model. In this case, I will select Z-axis plane and X-axis. To select my Z-axis, I can select any straight edge, cylindrical face, or flat face on the model. You can also select work geometry like planes or axes if desired. If either axis is placed in the reverse of the intended direction, we can reverse the axis direction by checking the Flip Axis checkbox. You can also orient the axes using the triad by clicking the stem of the arrow to define the direction and the tip of the arrow to flip its direction, making it quick and easy to set the WCS orientation. There are several options available for selecting our WCS position, none of which require entering coordinate values. Model origin will align the WCS to our model origin position. Selected point lets us position our WCS at any point on the model, including center points of round features. This option makes it easy to continue machining based on a previously manufactured feature. Stock box point allows us to place our WCS at a point on our stock box, and model box point allows us to place our WCS at a point on a bounding box that surrounds the model. In this example, I will use stock box point and select the center of the top face for our stock so that we can easily probe the origin during setup. It is important to note that if the models we use to define the WCS change, our WCS will also change. Keep this in mind when making late model or stock size changes. Next, we will navigate to our stock tab. In this tab, we can define our stock shape, location, and dimensions. Firstly, we will select our stock mode. Fixed size box will create a box around our part with defined absolute dimensions. Relative size box will create a box that is dimensioned relative to our model size. Fixed size cylinder and relative size cylinder afford the same functionality as their box counterparts, but will create a cylindrical profile. Fixed and relative size tube offer the same options as fixed and relative size cylinder, but allow us to specify an inner diameter. With the From Solid option, we can select any body in our design to use as our stock. It is worth noting that these bodies can be solids or mesh bodies. The From Solid option is useful when our initial stock is a complex shape, perhaps from a previous forging, casting, or additive process, to reduce the time spent cutting air. From Solid is also great when we are creating a setup for a side 2 of a previously machined part. For our current setup, I'm going to select the fixed size box option to create a box. I'll set the width to 2.5 inches and leave the model position as center. I'll set the depth to 3.5 inches and the height to 1.8 inches. I'll change the Z model position offset from top. This will place my stock beneath the part, giving us a good amount of material to hold onto in our vise. I'll set the offset to 50 thou so we have some material to face off on the top of our part. The last tab in our setup dialog is the post-process tab. Here we can specify a program number and comment. This is also where we assign our WCS offset number. This is the option that tells our post-processor which machine offset to use. Currently, my WCS offset is set to 0, which will correspond to my machine's first WCS offset, for example, G54. It is important to note that both WCS offset number 0 and 1 are linked to our machine's first offset. If I set my WCS offset number to 2, my machine's next WCS offset will be selected, for example, G55. Then this continues sequentially for all WCS offsets available on my machine. Now I can select OK and my setup will be generated, and we are ready to begin adding operations. Note that each operation within the setup will inherit that setup's WCS and stock material. The setup can now be found in the feature tree and edited at any time by right-clicking and selecting Edit. When we have multiple setups, it is important to ensure that we have the correct setup activated. Let's quickly take a look at creating our second setup, which will be responsible for machining side 2 of our part. I'll select New Setup, and you can see a new setup called Setup 2 is placed in the feature tree. As before, I will select my model and fixture geometry. I will also assign my WCS using the Select Z and X axis. Finally, I will set my stock origin as the top center of the stock using the Stock Box Point option. For this setup, I'd like our stock profile to represent the material left on our part after our first setup. To do this, I will navigate to the Stock tab and select the From Solid option. In the case of this part, I already have a mesh body which represents the stock left after my first setup, so I can navigate to my model geometry and select the mesh body as my stock profile. Now that I've generated my code, you can see that our Setup 1 program has called a G54 WCS offset, and on the right, our Setup 2 has called a G55 WCS offset. Now that we have created Setup 2, you will notice that the setup has automatically been activated in our feature tree. This is important as when creating toolpaths, they will automatically use the WCS and be placed under the active setup. So it's important to make sure that you activate the setup you want to work in when creating toolpaths. I will activate Setup 1 by selecting the button next to the setup name. The last thing I want to mention in this video is WCS probing. Fusion 360 can access the automatic probing cycles within your machine tool control and generate automatic probing cycles for setups. This is very useful when we have high quantities of the same part and we want fast, accurate, and repeatable setups. It is important to note that while WCS probing is fully integrated into Fusion and doesn't require an additional download or serial number, it is only available when supported by your machine tool controller. So be sure to check this before attempting to use this functionality. To create a WCS probing operation, I will navigate to the Probing tab and select the WCS probe function. This will create a WCS probing operation in my feature tree under my active setup and bring up a WCS probing dialog. Firstly, in the Tool tab, I will select the Probe tool from my tool library. Next, I will navigate to the Geometry tab. In this tab, I will set the probe mode to Stock. This will tell Fusion we want to probe our stock as opposed to the model geometry. For my probe stock surface, I will select the top face of my stock. You will notice that the probe type has defaulted to an XY rectangular boss operation. We could also change this to a Z level operation, which will probe the top face of our stock in Z. The approach value specifies the distance away from the feature that the probe will begin the measurement operation. In this case, it's the clearance from the X and Y walls. The over travel specifies the distance beyond the expected location that the probe will move before returning an error if no contact was made. I will navigate to the Actions tab and select the Override Driving WCS option. In the WCS override box, I will specify WCS 3. This means our probing operation will be driven from our machine's third work offset, G56 for example, but we'll set the new work offset values to our current active WCS offset. in our case G54. This means we are constantly driving our probing operation from the same coordinates as opposed to overriding our originally probed work offset, limiting the effects of creep. I will select OK for my operation and simulate my probing operation by right-clicking on the WCS probe operation and selecting Simulate. For a more in-depth tutorial of WCS probing, check out the Mastering WCS Probing course link in the upper right-hand corner. In the next video, we'll start creating some toolpaths and see how Fusion 360 makes programming straightforward with a consistent workflow across all toolpaths.